Okay, in the last class we are discussing about different 8086 programs. So, the next program is addition of a series of 8-bit numbers. And result is 16-bit. So, initially you have to assume some appropriate locations before writing the program. So, here I am assuming that this is the data segment. So, the starting address of this one is 50,000 H, as you have discussed in the earlier classes also. Ending will be 5FFH. So, I am assuming that with the offset of 5000, the length of array is stored, say 55,000 H. The offset from the starting of this address is 5000. Here I am storing length of array. LO is length of array. And first number is stored in the next location, second number and so on. So, I am going to store the result in two consecutive locations with offsets of say 6000 and 6001. Here I am going to store LSB and here MSB of the result. Now, with this assumption I will write the program. So, the first two instructions are same as the instruction that we have discussed in the earlier programs. Move AX comma 5000, because the data segment register points to the upper 16-bit address of starting of the segment. Then you can take on to data segment register. Then you point the first number. So, total length of array we have to store into some register. Okay. Here I am assuming that length of array is only 8-bit, means you can add at the most 255 numbers. So, move SI comma 5000 H, because the offset from here to here is 5000. That offset I am storing in SI register. Okay. Now, I am taking this length of array onto CL. So, that CL will be having length of array. Then the first number you have to increment this INCX, INCSI. So, the first number will be pointed by SI. Then you have to add the second number. So, for that move AL comma contents of SI, so that the first number will be taken into AL, because the result can be 16-bit. Okay. So, I am going to add 8-bit numbers continuously. So, here I am initiating some other register, say move dx comma or bx comma 0 0 0 0. So I am taking the first number into AL, then I am adding with AX also will make 0 0 0 0, can make, here I am going to write this, move AX comma 0 0 0 0 H, so that both AH and AL will be 0 0. Here I am taking the first number onto the lower order 8-bit register of AX, then I am going to add BX comma AX. So this instruction will add the contents of AX with BX and store the result into BX. Okay. I will explain this with some example also so that it will be clear. So after this addition, suppose if I want to add 5 numbers, say 1 plus 2 plus 3 plus 4 plus 5. How many additions you have to perform? Only 1, 2, 3, 4. So in general, if you want to add n numbers, we have to perform only n minus 1 additions. That is why here after this move CL comma SI, in CL we have length of array. So one way is you can directly store the length of array here, or you can store length of array minus 1 in 55,000 H, because if you want to add n numbers, only n minus 1 additions you have to perform. That is why instead of storing length of array here, I will store length of array minus 1. Okay. Then decrement DEC CL, jump not 0, up. Where should be this up now? So this should be here, because before going for that one you have to increment INC also, INC SI, because the first number I have added with the second number, then we have to add the third number with the first number. So like that you have to add. This is halt. Where should be up? Up should be here. I will explain with an example so that this program will be clear. Okay. Let us take the same numbers. I want to add 0 1H 0 2 0 3 0 4 so on up to 0 5. So I will store here 4 0 4, because if I want to add 5 numbers, we have only 4 additions. Okay. Now in the first iteration, after this CL will contain 4, AX will be 0 0 0, INC X SI means SIV points to 5001. The first number is this 0 1 here, 0 2 here, and so on. So after this instruction, AL contains 0 1. And what is AH? Because AX is cleared, so AH is 0 0 0 0. And if I add BX comma AX, in BX we have 0 0 0. After this, BX will contain 0 0 0 0 plus 0 0 0 1. This will be 0 1. So the addition will be BX was 0 0 0 0 and AX was AH is 0 0, AL is 0 1. So we will get 0 0 0 1 H. Then we are incrementing SI. So SI will point to the second number, the address of the second number. Then DCS CL. So CL becomes now 3. After adding the first number, DCS becomes 3 because to the 0. Then jump not 0 up, because this is not 0, it will go to the up, and because we have incremented SI, the second number will be taken into accumulator. So in the second iteration, accumulator AL will be having second number which is 0 to H, that will be added with AH is 0 0 only. So now in the second iteration, the addition that will be performed will be BX contains 0 0 0 1 plus AX contains AH is 0 0 and AL is 0 2. This will be 0003H. Similarly, CL will be decremented. Now it will becomes 2. Jump not 0, it will go up because INC SI is there. So SI will be incremented. So it will point to third number, which is 3. So in the third iteration, what happens? This will be there in BX, and AX contains AH is 00, AL contains 03. This will be 0006H. Then in the next iteration, fourth number will be added. Next iteration, fifth number will be added. So after adding all these numbers, so it will come out of the loop. Okay. So because we are adding this first number to 0, we require length of array should be here. It should be length of array only. This will be 0, 5. Okay. So this is about this addition of series of 8-bit numbers. Actually here if I add two numbers at the same time, 1 and 2, then the sum of this with 3, sum of this with 4, sum of this with 5, then we require 4 additions. But here what I am doing is, I am taking first 0, I am adding first 1, then 2, then 3, then 4, then 5. So we have total 5 additions. Okay. So length of array we have to take in 5500 instead of length of array minus 1. So this is about the addition of series of 8-bit numbers, result is 16-bit. So the next program is finding the larger of a series of numbers. Or to find the largest number from an array. To find the largest number from an 8-bit array. Here also you have to first assume the appropriate memory location before writing the program. So I will take the same data segment address. $50,000. So data segment register point to 5000. And I am assuming that length of array is with the offset of 5000 H. Then the first number in 5501, second number in the next location, and so on. And I am going to store the result in location, because this is only 8-bit, we need only one location, 5600H. This is my specifications of the address. Then the first two instructions will be same, move AX comma 5000, move DX comma AX. Then to take the length of array into CL register, the same instructions which you have used in the earlier program. Move SI, I am pointing SI to the offset of length of array, which is 5000H. Move CL comma contents of SI, then increment SI, so that SI will pass to the first number. Then you have to compare with first two numbers. So move AL comma contents of SI, compare AL comma contents of SI plus 1. Okay. So with these instructions, CI will point to length of array, and first number I have taken into AL, second number I am comparing with AL using compare instruction. Second number will be there in SI plus 1. So, SI was after this increment 5001, SI plus 1 becomes 5002. First two numbers will be compared. Okay. Now, my logic is here, I want to keep always the larger of this number into AL. Okay. If AL is already having the larger number, then after this comparison operation, what happens to carry flag? So, carry flag will be set if a borrow is needed or if this subtrahend is greater than minuend. Okay. So, here if AL is greater than SI plus 1, AL is greater than SI plus 1, then carry flag will be reset. If AL is less than SI plus 1, then carry flag will be set. Okay. So, if jump no carry down, so when does this will be true? No carry if AL is already larger. In that case, we have to go for comparison of the third number. In case if this is false, means if carry flag is set, then what you have to do, SI plus 1, that is the second number is larger than the first number, that I have to take into accumulator. So, further the instruction will be move AL comma contents of SI plus 1. So, at this point, in any case AL will be having larger of these two numbers. Okay. If AL is larger directly here, this will skip this one because carry will not be result. So, it will come out of the loop. Otherwise, the contents of SI plus 1, if it is larger than AL, then that will be taken into AL. So, here we have to write the down program. So, comparison of the first two numbers is over. Then you have to go for the third number, which is stored in 55,003H. Okay. For that we have to increment SI, so that now SI will points to, here SI was 5000, after this 5001. So, this is 5001 and this is 5002. So, it compares first and second number to point to 5003. So, we are incrementing this SI, so that SI plus 1 becomes 5003. Okay. Now, I am not going to take any number onto AL. DEC CL jump not 0 up. This up I will take to direct comparison operation. Okay. So, what happens now? So, compare AL. So, between these first two numbers, the larger of this number is present in already AL, because if AL is having this larger number, I will just skip these instructions and I will go to the jump. If second number is larger, I am going to replace second number onto AL, then I am going to go for the next comparison. Okay. So, in any case, this AL will be having, after this particular first loop, first iteration, AL will be having the larger of the first two numbers, that I am going to compare with the third number. So, here this SI will points to now, this was 5002, I have incremented by 1. So, now it will becomes 5003. So, 5003 will be third number, and in AL what will be there? The larger of the first two numbers. So, I am going to compare the larger of the first two numbers with third number. Again the same logic, if this no carry means AL is the contents of, that is the larger of the first two numbers is larger than third number also. Otherwise, third number which is there in SI plus 1, I am going to replace into AL. Okay. Same logic. So, at the end of this loop, what happens? AL will be having the result, that we have to store in this 56,000H. For that, move SI, we can use BX BP also, because SI have used, but the purpose of SI is over, I can use the same SI for some other purpose. So, 6000H, and where the result is there in AL, I am going to store into SI AL. This is alt. Okay. I will explain this also with an example, so that it will be clear whether I have to store the length of array here or length of array minus 1. Like in previous case addition, it is length of array only, because we are adding 0 each number to the 0. So, that is why the number of array, length of array is equal to number of additions, whereas here, so I am comparing the first two numbers. So, here probably this you have to store length of array minus 1. This will be clear if I take one example. You take the same 5 numbers. So, if I take 5 numbers here, so probably this is equal to 4, I am going to prove this. Okay. So, 5 numbers are in 5000, 50,000, 1. So, you have first number, second number, third number, fourth number, fifth number. This is some 20, this is some 40, this is some 50, this is from 10, this is from 80, say. Okay. So, I will explain this with this particular set of data. So, initially I am going to store CL with 5. So, I will come to that point. So, whether we have to store 5 or 4. So, I am taking CL with 5. Okay. So, here CL with the 5 first. Then AL I am taking the first number, which is 20 in the first iteration. Then I am comparing 20 with 40. So, in this comparison, because SI plus 1 becomes 55,002. So, I am comparing 20 with 20 minus 40. This is the operation that is performed in the comparison in the first iteration. So, for 20 minus 40, what happens? Carry flag will be set, because this requires borrow. So, carry flag is set. So, jump not carry, this will be false. So, what happens? This will skip and it will go to this instruction. So, SI plus 1 contents will be 40. So, this AL will be loaded with now larger of the first two numbers, which is 40. So, we have compared the first two numbers in the first iteration, this one, and AL will be loaded with 40. So, after that I am incrementing the SI, so that SI will punch to 5002 and CL I am decrementing. So, CL becomes 4, because this is not 0. So, it will go to up. So, in the second iteration, what happens? Compare AL. AL is having 40 after the end of the first iteration. And what is SI plus 1? SI was after this SI increment 5002. SI plus 1 becomes 5003. In 5003, what is there? 50. Now, here AL contains 40 and SI plus 1 will be 50. So, these two will be compared. So, 40 minus 50. As you have discussed in this instruction set, compare means the operation inside this comparison is subtraction only. Okay. The difference between the compare and subtraction is, in case of compare, subtraction is performed and the result is discarded, whereas in subtraction the result is also stored. Here, depending upon the subtraction result, it will set or reset the flags. So, now what happens to carry flag? Here the carry flag will be set, because borrow is there. Here also carry flag will be set, because borrow is needed. Okay. So, now what happens? So, because this is false, so the contents of SI plus 1, which is 50, will be taken into accumulator. Now, CL will be decremented by 1. CL will be decremented by 1. So, CL becomes 3. So, because this is not 0, it will go to the up. Before that, it has incremented the SI by 1. So, that in the third iteration, AL will contains the largest of the first three numbers, which is 50, and SI plus 1 points to now the fourth number, which is 10. Then here again comparison means 50 minus 10 will be performed. Because 50 is larger than 10, carry flag will be reset. So if this carry flag is reached, jump not carry. So this is true. So this will go to the down, it will skip this operation, move AL comma SI plus 1 operation. Okay. Now AL will be containing this, again increment SI, then decrement CL, CL becomes 2, CL becomes 2. So that in the fourth iteration AL was 50 only as it is, because the 10 number, the fourth number was less than 50. So AL remains 50. Now SI plus 1 will point to the last number, which is 80. So here 50 minus 80 will be performed, carry flag will be set because 50 is less than 80. So if carry flag is set, this is false, JNC down is false. So it will exchange this AL with SI plus 1 contents. So AL will be having 80. So then this 02 becomes 01, but comparison is already over. So this should be 00. So that is why here you have to take length of array minus 1. Okay, is it clear? Now already this AL is having largest of the first 5 numbers. So this, if I take here length of array minus 1, this will becomes 00. Then it will come out of the loop. Now AL is having the largest number, that you have to store in the memory location whose offset is 6000. So for that I have taken SI with 6000H, and I am storing this largest number in that particular memory location. So this is about to find the largest from a series of 8-bit numbers. Okay. Suppose if I want to find out this smallest, instead of largest, if I want to find out the smallest. So the only difference is, instead of JNC, if I write JC, this will find the smallest number, because I want to always keep smallest number in AL. Okay. So for that I have to check for jump on carry. Okay. If already AL is having smallest number, smaller of 2 numbers, then so jump on carry, this will be true, it will go to the next comparison, otherwise it will replace with the smaller of these 2 numbers. Okay. So we can check this operation. To find out the smallest, you have to replace JNC with JC. Okay. The remaining all operations will be same. Now this is finding the largest or smallest number from an array of 8-bit numbers. Suppose if you have an array of 16-bit numbers, so you have almost similar program. Okay. So we have only few changes. So the next program is to find the largest number from a series of 16-bit array. Same thing again. So I will start for any program. This is the important thing, is you have to assume the appropriate memory location before writing the program. So data segment register, FFH, then assume that length of array is, of course here also you have to store length of array minus 1, because of the logic that I have explained in the earlier program. You have to store length of array minus 1. I am storing this in 55,000H with the offset of 5,000H, and the array starts from the next location onwards, which is 55001H, 55002H, 55003H, 55004H, and so on. and I am storing the result in 56,000H and 56,001H. Here the first number LSB of this one, here MSB is here. Here second number LSB is here, MSB is here, and here the result LSB is here, MSB is here. So as you have seen, we are going to use the same logic. That is why here you have to store length of array minus 1, because the number of comparison will be 1 less than the length of the array. Okay. Suppose if I want to compare 1, 2, 3, if I compare with 0, 1, 2, 3, 3 comparisons. Okay. If I compare the first two numbers in the first iterations, so we will find out the larger of this one, which is 2. This I am going to compare with 3. So, we will get 3 result, only 2 comparisons. Okay. So, always you remember that whenever you want to compare with 0 or in addition also, if I directly perform the addition of two first numbers, then the number of additions should be less than the length of array. If I add with 0, if I compare with 0 as a first step, then length of array is equal to the number of additions or comparisons. Okay. Now, what is the program? So, I will repeat the first two instructions. Move Si, comma offset of the length of array minus 1. Then take into CL, CL will contain length of array minus 1. Then the first number is there in INC SI, so that SI points to the first number. So, we take this on to AX, so because the destination register AX is 16-bit, if I write contents of SI, it will take a word from the SI. Otherwise, you can write word PTR here, but it is not required. Then we have to compare the second number which is stored in AX comma contents of SI plus 2. Here SI was 55,001 and SI plus 2 becomes 55,003, where the second number is stored. Okay. Jump not carry down means already AX is having larger of the first two numbers, the same logic. Okay. Otherwise, what you have to do, you have to exchange with SI plus 2 contents. And down will be here, where we are going to, because one comparison is over, we have to decrement CL. Before that, you have to increment SI twice, because this is 16-bit number. This is one of the difference. INCSI, INCSI, or you can write instead of this add SI comma 0002H. These two are same, but we will prefer INCSI only, because this is single byte. Here we have this single byte and there are 4 hexadecimal digits, means 2 more bytes. Okay. So, INCSI, then DEC CL. Here also, if I want to use the loop instruction, I can make this into CX. CH you can make as 0. So, in that case, if I make this CL into this one, or directly contents of SI onto CX. So, here anyhow this will be 2 bits only. So, if I make here move CL CH comma 0 0, so that CX will be having lower order 8 bits will be that length of array minus 1. Then instead of this DEC CX, I can write directly loop also. Okay. So, D is jump not 0 up. If I use this move ch comma 0 0 also, instead of these two instructions I can write directly loop up, because inside the loop we have decrement of cx by 1. Okay. Up, where should be is up, this comparison. So, at the end of this loop Ax will be having largest number that I want to store in 56,000 H. So, I am taking move Si comma, the offset is 6000 H, move Ax comma contents of Si. Right. So, this is the program which finds the largest number from a series of 16-bit numbers. Okay. And similarly, if you want the smallest number, you have to replace J and C with JC. Okay. So, this is about this program. The next program that I am going to discuss is to find the even and odd numbers in a array, 16-bit array. Okay, to find the even or odd numbers from an array of 16-bit numbers. Okay. So, you have to assume the appropriate memory locations. H, data segment register will be 5000 H. This is data segment of 64 kilobyte. Then I am assuming that length of array is in 55,000 H. So, I will come to this point whether this should be length of array or length of array minus 1. Okay. Then the first number will be next locations 55,000 H, 55,002 H. The first number LSB of this one, MSB of the first number. Similarly, second number LSB, MSB, and I am going to store result in 56,000 H, 56,001 H, LSB, MSB. Here basically the logic to find out this even and odd numbers is, if I check only the lower LSB bit, it is enough. Okay. If LSB bit of 16-bit number is 0, implies even number. If LSB of 16-bit number is 1, implies odd number. So, to store this number of even numbers and odd numbers, so I am going to take two registers. Okay. So, the number of even and odd numbers can be, because I am taking length of array in only single bit 255 only. So, at the most they can be less than 255. Okay. So, for that I am taking move say D H comma 0 0, move DL comma 0 0, I want to store here the even numbers, number of even numbers. I want to store in DL number of odd numbers. Okay. So, the first two steps are same, I am not repeating here. So, move AX comma that, okay, that you can write. Then move SI comma length of array, contents of 5000, move CL comma contents of SI. So, CL will points to length of array, or it can be length of array minus 1. So, I will find that value at the end of the program. Then you have to find out the first number. You take the first 16-bit number into AX, any other register. Move, this is INC SI, so that SI will points to 55001, where LSB of the first number is present. So, I am taking the first 16-bit number directly into register AX or any other register for that matter. Move AX comma contents of SI. So, AX will be having first number. So, I am going to rotate to get this LSB bit. I have rotate instruction. Okay. So, in the rotate instruction, if I write ROL AX comma 01, if I want to rotate by only one bit, you have to write the register followed by that one bit. If you want to rotate by more than 1 bits, you take that into CL and you write CL here. This we have discussed in the instruction set. Okay. In ROL, as the name implies, rotate the contents of this AX register to the left. Okay. Here carry flag will be there. Sorry, this should be R, because I want LSB bit. So, this should be right. Here the carry flag will be there. So, this least significant bit, which is A0, this is A15. So, this A15 will go to A14 and so on. This will go here. This will go to carry as well as this will also go to A15. This is what the operation inside this RORX. So, whatever this LSB bit will go into carry flag. Now, you just check the carry flag status. Okay. Jump on carry. Jump on carry means what does it mean? If this is true, is it an even number or odd number? If carry is there means LSB bit is 1. LSB bit is 1 means it is a odd number. Go to odd, where I am going to increment DL register. Otherwise, you have to increment DH register. DH was initially 0. If this is false means obviously that number is even number. So, you have to increment the even register, which is DH. INC DH. Okay. Then odd here. If the number is odd, without incrementing the DH, it will increment only DL. So, increment DH and then it will jump to the next comparison, jump to down, because number can be either even or odd. Once if it is found that this is odd number, then no need to increment this DH, it will go to the next comparison. Otherwise, it will increment the DL and then it will go to the next comparison. Next comparison is here, we are going to increment INC SI, this is down, again INC SI, because this is 16-bit number, you have to increment INC by twice, so that it will point to the second number. which is 55,003. Okay. Then we have to write DEC CL. So because you have checked the first number, so here only checking of the number, there is no comparison and addition. So in 55,000 we have to store only length of array. Okay. So DEC CL, jump not 0, up. Where should be up now? This. You are taking the second number into AX. You have to take the second number into AX. So move AX comma SI, so that this second number will be taken into AX. Again you are rotating the second number. So we will find whether this is even number or odd number. If it is odd number, we are going to increment DL. If it is even number, we are going to decrement only DH. And after each checking, we are going to increment the SI by twice, and we are going to decrement by CL 1. So until that CL is equal to 0, we will repeat. So I want to store this, instead of LSB, MSB, I will store even and odd. Otherwise, I want to store the number of even numbers, number of odd numbers. So at the end of this loop, where the number of even numbers is there in DH, so you initiate move SI comma 6000 H, move in 6000 I want to store the even is there in DH. So I will store contents of SI with DH and move contents of SI plus 1 with DL. As I write here, I will write here move contents of SI plus 1 with DL, then halt. So this is the program which finds the number of even and odd numbers in an array of 16-bit numbers. Okay. In simple logic is we are going to check the LSB bit. If LSB bit is 1, it is a odd number. If LSB bit is 0, it is a even number. Okay. So like that we are going to write this program. So the next program is to find the 2's complement of a 16-bit number. Okay. Suppose if the 16-bit number is present in a data segment with the offset of same 5000, 50,000, and in 5000 we have 16-bit number 55,000 H and 55,000 1H. This is LSB, this is MSB of the number. So in order to find out the 2's complement of a number, okay, so I will take first this number onto AX, move SI comma contents of 5000 H, move AX comma contents of SI. Okay. Now to get the 1's complement of a number, there is an instruction called negate. So I will take the 1's complement, then I will add 1. Okay. And you store the result back onto the same 55,000 H and 55,000 1H. Okay. You store the result back onto this. So for that you write neg negate AX, so that AX contents will be complemented, this 1's complement, then add AX comma 0001, so that you will get 2's complement, and you have to store this again into the same location. So you have to store back move, this is reverse operation. Okay. Here you have transferred this number onto AX, now In AX we have the 2's complement number, that I have to transfer onto the SI. Move contents of SI comma AX, then alt. This is a simple program which computes the 2's complement of a 16-bit number and it replaces the original number with its 2's complement. Okay. So, I will discuss some more programs in the next class. Okay, thank you.